We're going to start Unit 2, and Unit 2 is all about radicals. So the first lesson is actually, well, the first part of it is kind of like a review. We are going to look at radicals with numbers, and later on in the lesson, we'll actually start looking at radicals with variables, as you can see on the second page, okay? But the first page, that's what we'll do first. We'll do some reviewing. Okay, so we are going to arrange these radicals in order from the smallest to the biggest. Okay, so, and again, we are doing this with our calculator. So then you might think, okay, well then how am I gonna, how am I supposed to know which number is bigger? Well, what we can do is we can change all these mixed radicals into entire radicals, because once we do that, we can actually look at the radicands. Okay, remember radicands are just the numbers inside the radical sign, and I mean, obviously, when you square root a bigger number, the end result is going to be bigger than the square root of a smaller number. So what we're going to do is we are going to turn this, or all these numbers, into entire radicals. And recall, to do that, what we do is we take this well, not really a coefficient, but this number right here, 3, we are going to move it inside the radical. And so recall that 3 really came from 3 times 3 inside radical, right? Because then we have 2 of them. When we square root it, it becomes just 1, 3. When we take it outside, we still have the 5 inside there. So if you multiply them together, 3 times 3 is 9, 9 times 5 is 45. And you can do the same thing for the next 2 radicals. That becomes 5 times 5 times 2, and 5 times 5 is 25, times 2 is 50. Finally, we have 4 root 3, so that's square root of 4 times 3, which is going to be square root of 48. Okay, now you can see clearly this would be the biggest, right? Root 50 would be the biggest, and root 45 would be the smallest. Since we're arranging them from smallest to the biggest, so I guess we go 3 root 5 is smaller than 4 root 3, which is smaller than 5 root 2. And that would be the answer. And that's how you arrange them, from smallest to the biggest. Okay. Similarly, with part B, we have 2 cube roots, and we actually have 1 square root right here. But you know what? We're going to do the same thing. We're going to convert everything into entire radical first. So we have 2 times cube root of 6. Which means this is going to be the cube root of 2 times 2 times 2 times 6, which is cube root of 48. We have 3 times the cube root of 2, and this really is the same thing as cube root of 3 times 3 times 3 times 2, and that's 27, so 54. Okay, finally we have 3 times root 7. This is simply 3 times 3 times 7, which is 63. Okay, so now I think it's clear. If we compare the first two, cube root of 48 is smaller than cube root of 54. Now, let's think about this. Would cube root of 54 be smaller, or would root 63 be smaller? Well, because it's cube root, okay, and this number is smaller than 63, so cube root of 54 will be smaller. I mean, what if this was a 54? What if this was a 54? Then cube root of 54 will be smaller, right? Because if you think about it, cube root means we are multiplied by itself 3 times, right? We're looking for a number multiplied by itself 3 times to get to 54. So that number actually is going to be smaller than, let's say, to find a number multiplied by itself twice to get to 54. Okay? So even if they are the same, cube root of 54 will be smaller. Let alone this time is actually square root of 63. So I think this one's clear. 2 cube root of 6 is smaller than 3 cube root of 2, which is smaller than 3 root 7. Okay, so now there are 3 questions for you to practice. Give it a try. Okay, I will do it quickly. Please check your answer. So that's root 50. 2 root 5 is the same thing as square root of 2 squared times 5, which is root 20. 4 root 3 is the same as square root of 4 squared times 3, which is root 48. Okay, so then in this case, 2 root 5 is smallest, followed by 4 root 3, and then 5 root 2. Okay, so that's the first one. Second one, so now it's cube root. So this is going to be the cube root of 9 cubed times 2. Okay, now that's a huge number. I have no idea what this is. I gotta pull out my calculator here. So 9 times 9 times 9 times 2 is 1458. Okay, now don't worry about it. Like I said, your test will be done without calculator. I will not give you such a big number, okay? It's 11 cubed times 3. So that's 11 cubed times 3. This is 3993. Finally, 8 times cube root of 17. This is 8 cubed times 17. Okay, so 8704. Okay, so I think this one is also clear. 9 cube root of 2 is smaller than 11 cube root of 3, which is smaller than 8 cube root of 17. That's the order. Oops. All right, part C, 8 is simply just 8. Okay, this one is kind of tricky, okay? Okay, so I will show you this one here. So 8 is just 8, okay? Now we have 3 times cube root of 2. Okay, so since all these three are all, they all have different index, and actually, in fact, 8 is not, well, I guess you can turn it into a square root. What we can do here is we can actually kind of estimate here, okay? Cube root of 2. So if you think about a number multiple itself 3 times to get to a 2, this number is only going to be 1 point something, right? Because if you think about 2, okay, 2 times itself 3 times is 8 already, which is way bigger than 2. So it has to be less than 2. If you think about 1 times itself 3 times is 1, but 2 is bigger than 1. So cube root of 2 is 1 point something. I would say lower end of 1, right? 1.1 or 1.2, something like that. Something small. So really you're thinking about 3 times 1.2-ish, something like that. Okay? So which is actually less than 4, right? And you have 3 root 10. I'm gonna write out the whole thing. Okay, so this is 3 cube root of 2. This is approximately 3 times 1.2. So this is around 3.6. Okay, approximately, obviously not entirely correct. 3 root 10. Now root 10. So if you think about square root of 9, okay, because that's a nice number, root 9 is 3. And root 16 will be 4. So root 10 is going to be somewhat close to 3. So I'm going to say maybe about 3.1-ish, right? So 3 root 10 would be approximately 3 times 3.1-ish, which is 9.3. Okay, so then I think if you do it this way, it's clear that 3 cube root of 2 is smaller than 8, which is smaller than 3 root 10. Okay, so in this case, you can't just compare radicals. You actually kind of need to estimate it, turn the radical into a decimal, and then multiply. Okay, so you might want to watch that part again, if you didn't understand what I was saying. Okay, so make sure you understood what I said. Okay, watch it slowly. I think I explained everything there. Okay. All right, moving on, division property of radicals. We've seen this before already in the first unit. I didn't write this down, but I mentioned it verbally, okay? It was mentioned. Okay, so then let's take a look. Here we are writing the cube root of -40 out of 81 as a mixed radical. So recall, it's a cube root, right? So you are looking for a factor of both 40 and 81 that's also a perfect cube. So I can do this right now. I know. So first of all, I'm going to actually split. Okay, I'm going to split this into cube root of 40 divided by cube root of 81. And I know -40 is the same thing as -8 times 5. Okay, and again, I use -8 because that's a perfect cube. which is negative 2. 81, that is the same as 27 times 3. Okay, so cube root of 27 is a 3, so that's why I put 27 there. So then I have cube root of negative 8, which is negative 2. And then cube root of 27, which is a 3. And I still have the cube root. Now, once I took out these two numbers out, I can actually put the 5 over 3 back as one single radical again. Okay, so that's how I got this. Okay, again, 5 goes on the top, 3 goes in the denominator. Okay. Part B, write this as an entire radical. So here we usually keep the negative sign outside. Okay, so we actually don't take the negative sign and move it inside. So when we have negative 2 times the 4th root of 3/4, what we are going to do is we're going to keep the negative sign out, and we are going to put the 2 inside. Okay, so remember that's a 2 in the numerator because it's 2 over 1, right? So we're going to put 2 in the numerator. So this is going to be 2 times 2 times 2 times 2 times 3. Okay, or you can just write it as 2 to the power 4. Okay, that might be easier. But the reason why I'm doing this is you can see that's 2 times 2, which will cancel out with that. Okay, so then this is going to be the negative sign 4th root of 2 times 2, which is 4, times 3, which is 12. Okay, so it's the negative 4th root of 12. And there you go. Okay, so first page is just a review. Okay, hopefully it wasn't too challenging for you. We are now going to be looking at radicals with variables now. Okay, so this is something new. Okay, so the first question it's asking us to do is determining when a radical is defined. Okay, we're looking for when a radical is defined. So what does that mean? What does that mean, radical is defined? So if you okay, so what you need to think about is when okay, so for example, can I put this into calculator and is that going to work? Yes, that's going to be fine. Okay, is that going to be okay if you put that into calculator? Yes, this is going to be okay because that's a 2, that's a 0, that's fine. But what if we put a negative sign inside the square root? Is that going to work? No, this is not going to work. Okay, so this does not work. And this is when the radical is not defined. So these are okay, but this one is not okay. So this is when the radical is not defined. So basically the radical, okay, we're talking about square roots. And when we we cannot square root negative numbers. And if you look at the first example here, 30 times x cubed. So is there a number that we put into x and that will make this radical undefined? Which means, is it possible to make this radicand negative? The answer is yes, of course. If x is negative, then this is going to be negative. Okay, so what I'm saying here then is x, for this radical to be defined, x has to be greater than or equal to 0. Right? Again, I'll give you an example. If, let's say, okay, if x equals -1, let's say, okay, then this becomes square root of 30 times -1 cubed, which is 30 times -1, which is the square root of -30. That's not possible. We can't do that. Okay, we cannot take square root of negative numbers. So this is not okay. And that's why I have to say that x has to be greater than or equal to 0 in order for this radical to be defined. Okay, this is not okay. Okay, this is good. Okay, what about part B? Now, the difference between part A and part B is that this is cube root. Okay, it's odd index. Okay, odd number index. Now, so then if we do the same thing, can we cube root 1? Sure, that's 1. Can we cube root 0? Yes, that's 0. Can we cube root -8? Yes, that is actually okay. We can actually cube root negative numbers, right? Because negative times negative times negative, when you multiply negative 3 times, it's negative. So, in example B, x could be anything, right? Because it does not matter what we put into x, it'll be okay because we are taking the cube root, okay? So in this case, x would be the element of all real numbers, okay? Meaning x could be anything. Okay, it could be any numbers that we learned so far. Okay, it could be pi, it could be -7, it could be anything. Okay, so that is that. Okay, so the moral of the story here is that when we have odd number as the index, x could be anything. However, when the index is an even number, that's when we need to be careful, okay? X sometimes can be anything, but sometimes it has to be positive only. Okay, you know what? I'll give an example when x could be anything. I don't think I gave you an example here. Let's say that let's take a look. Fourth root. Okay, so what if we say that this is fourth root of 5x squared? In this case, x could be anything, and the reason why is because even if x is negative, because we're taking the square first, and we know when we square a negative number, it actually turns into a positive number. So then this radicand is actually going to be a positive number. In that case, sure, x could be negative. That's fine, because we can actually take the fourth root of a positive number. So what that means is this will never be negative, right? If that's never going to be negative, then x could be anything. Okay, so that's how you figure out when a radical is defined. Okay, so there are 2 questions for you to try. Good luck. Okay, part A, I think that one is easy because it's a cube root, so x could be anything. Okay, so again, if that's a 3, that's a 5, that's a 7, as long as the index is an odd number, it could be anything. Part B, this one is slightly trickier. Let's see. We have even number index, right? The square root. We have x squared here. Then you might think, oh, okay, well, that's great. That means x could be anything. No, okay? In this case, this radical will never be defined, okay? Never be defined. And why is that? Well, defined. Because x squared is always positive. And we are taking a positive number multiplied by a negative number, which means the radicand will always be negative. We will never be able to, oh, actually I'm wrong. I shouldn't say never be defined. There's an exception. X could actually equal to 0, right? When x is 0, negative 5 times 0 is 0. We could definitely square root 0, but that is the only number that x can be. X cannot be positive nor negative, because when you square positive or negative numbers, it actually turns into a positive number. Positive times negative is negative. We can't square root negatives, except x can be 0 because we can square root 0. Okay, so this one is a little tricky. Okay. All right. Okay, so we're going to look at the last example here. We are going to simplify radicals, and we do have variables inside here, and we need to first define the radicals. Okay. So in this case, we're taking the square root of 75a squared. It's an even root, okay, even index, so we need to be careful. It's a squared, so it's always going to be positive, and positive times positive is always positive. So in this case, a could be anything. Okay, now how do we simplify the radical here now? Okay, so we are looking at 75 here. So 75, we can turn that into 25 times 5, and then times a squared. Okay, 25 square root of 20. Oh, sorry, not times 5, times 3. Square root of 25 is 5. Square root of a squared. You might think that, okay, so this is like square root of 2 squared, right? Or 2 times 2. And there are 2 numbers that are the same. So recall, if it was just numbers, then we're saying that, okay, that's a 2, right? So you might think, okay, so I guess that's a squared, so that's a times a. So the square root of a squared is simply just a. Okay, so this is where, you know, this is slightly trickier than you might have thought, okay? It is a for sure. However, we need to write this symbol right here, and this means absolute value. And what that means is that absolute value, what it does is it makes the number to become positive at all times. Okay, so let me explain that a little bit more after finishing writing the answer here. So this will be the answer: 5 times the absolute value of a times root 3. So let me first of all explain to you what absolute value does. Okay, so that's simple. 2 bars. Absolute value of 2 is 2. Absolute value of negative 2, however, is also 2. Absolute value of negative 10 is 10. Okay, so again, these two lines, absolute value, symbols, what it does is it makes it positive. Now, you might think, okay, so then why do I need it for a here? Okay, well, why, right? Why? Okay, so here is the reason why. Let me do it on the side right here. Okay, so let me give you an example. Okay, let's say, let me just say something. Okay, let me just say square root of a squared. So if you think this is just a, okay, then it's actually wrong. Okay, and here's the reason why. Let's give an example here. Let's say a is 2. Let's say a is 2, right? So in this case, this is actually square root of 4. I'm going to write down everything. 2 squared, so that's square root of 4, so that's 2. So in this case, oh yeah, Mr. H, then what's wrong with that, right? I mean, that's exactly what it is. You're saying a is 2 and a is 2. The end result is 2 here. Okay, so true, okay. However, what if I say that a is negative 2? Well, then this becomes square root of negative 2 squared. Which, I mean, negative 2 squared is 4. And that's 2. A is negative 2. That's not negative 2, that's positive 2, right? You can see that, that's positive 2. They are not the same. They are not the same, right? Right? If you say that square root of a squared is a, well, then you can see the square root of a squared, right? That clearly is a squared, is not a. It's actually absolute value of a, okay? There you go. That's why you need the absolute value symbol, okay? Yeah. I think that explains it, right? You can see it with your eyes. That's negative 2, but that's positive 2. They are not the same. However, if you put an absolute value sign there, then it becomes a 2. Okay? So really, we put an absolute value sign to cover our butt, right? What if a is negative? Because you can see a definitely can be negative. A could be any number here. So we need to put absolute value sign there to make sure that we make it positive. Okay, because the answer, when we take the square root, the answer is always positive. Okay, but you can see, and you can see, I mean, you can see here, right? It's positive 2. Okay, part B, for what value of x is this radical defined? Well, it's a cube root, so x could be anything. Okay, can we simplify this? No, we can't. Okay, there's no perfect cube factor for 15. So there you go. That's it. There's nothing we can do about it. And this is just x. We need to have at least x cubed to actually take out the x, right? Just like that. Okay. I don't know if that's enough example. You know what? I'm going to do 2 more, and I'll let you try the last 2 there. Okay. Okay. First of all, it's a square root. Let's figure out what we need to. How are we going to define b so that this radical is defined? It's a 5th root. So b really has to be greater than or equal to 0, okay? Because if b is negative, then you end up with a negative number. You cannot square root negatives. So b has to be greater than or equal to 0. Now, can we simplify this? The answer is yes, okay? And how do we do that? Okay, so now let's see. We can rewrite this as 15 times b squared times b squared times b. Right? And the reason why I split b to the power 5 into b squared times b squared times b is because we can actually square root of b squared, right? Twice. And we know the square root of b squared is going to be b. And we have another one right here. So it's going to be b times b, so it's b squared. And we still have 15b inside the radical. And you might be like, okay, so what is this? How come this time we don't need absolute value sign here? Why? Okay, so really there are 2 reasons. Okay, so first of all, we already said that b has to be greater than 0. So we don't really have a negative b case. Okay, so we already eliminated that. Also, b squared right here is always going to be positive. So we will not end up with a negative answer, right? So that's why we don't need absolute value sign in this case. Right? We actually don't need it. Okay, again, first reason is because we already defined b has to be bigger than 0. Okay, part B, let's see here. Now this can be simplified. We're actually going to define e first. E to the power of 7, so this time e has to be again greater than or equal to 0, because if e is negative, negative to the power 7 is negative. We cannot fourth root negative numbers, okay? So now we can actually change this. 80 is 16 times 5. And again, e to the 7, I'm going to change that e to the power 4 times e cubed. Okay. So now, the fourth root of 16 is 2. The fourth root of e to the power 4 is simply just e. And there's nothing we can do about the 5 and the e cubed. So we are going to keep those inside. So that's just going to be 5e cubed. Okay. Now, what do you think? Do we need to put absolute value sign for e in this case? The answer is no. Okay, because you already defined e is bigger than or equal to 0. So this will never be negative. So now we're okay. If you don't define that, then you will need to put absolute value sign there. Okay, if you do not define e is bigger than or equal to 0, then you will need that. Because, I mean, the same situation as the square root, when this is just e, not a square, it could be negative. Okay, so be careful. If you define it, you don't need to worry about absolute value sign. If you don't define it, then in that case, you'll definitely need it. Okay, so last 2 questions for you to practice. Good luck. Okay, so this one, x could be anything because it's a cube root. Y could be anything because it's a cube root. In that case, we actually don't need to worry about absolute value sign anymore because there is cube root. It doesn't matter. Okay, the answer could be negative. Okay. So I am going to change 16 into 8 times 2 because I know cube root of 8 is 2. X to the power 5 is, I'm going to change that into x cubed. I'm going to put dot instead of times, simple. And then times x squared times y cubed times y cubed. Okay, so cube root of 8 is 2. Cube root of x cubed is x. I have cube root of y cubed twice. So I'm going to have y squared outside because 1 y each for one of these two, right? And then I still end up with 2 inside and x squared inside the radical sign as the radicand, I guess. Okay, so that's part C. Part D is a fifth root. Again, it's odd numbers. So then again, x could be anything and y could be anything. Okay, and now fifth root of 16, there's nothing I can do about that. However, I can do something about the x and the y. Okay, well, x is just to the power 5, that's perfect. Y to the power of 11, I'm going to change that to y to the 5, y to the 5 times y. Okay, I think hopefully you don't need to do this after you feel practice. You can really just do y to the power of 10. And then, you know that they're 2 5, so then when you take the fifth root, you know that they're going to be y squared outside. Anyways, you might not know that just yet, but I think as you do more, you'll notice that, okay? Again, there's nothing I can do about fifth root of 16, but I can do something with the fifth root of x to the 5, that's just x. And then I have fifth root of y to the 5 twice, so that's going to give me y and another y, so it's y squared. And now I still have 16 inside and the y inside, and that is my final answer. Okay, so this lesson could be a little bit tricky, okay, especially on the second page when we deal with variables and absolute value symbols, okay? So do some practice questions. Let me know if you need help. Again, watch the video again if you need it to, okay? Good luck.